Hello guys, welcome to the 10th session of this crash course series. Before getting into chemical kinetics, I would like to tell you an important announcement, that is mock test. So we are going to conduct an open mock test for all those JEE main aspirants. So what you have to do is, from tomorrow you will be getting a link for the mock test. Once you attend the mock test, we will give you the mock test paper analysis as a video. So where we will be discussing all those questions what are asked in the mock test. So this mock test is fully of anticipated questions for this JEE Main 2025. So don't miss out this opportunity. Once you finish the test only, you will get the paper analysis. So please do attend the test. From tomorrow, we'll be releasing 5 series of mock test. So please be attentive. Please watch out our videos. Okay. So with this introduction, I would like to start chemical kinetics. Talking about this chapter, this is very important in JEE Main perspective, where we will be discussing the rate laws and how it is affecting what are the factors affecting the rate law, and most importantly Arrhenius equation, catalysis. These are the segmentation or analysis of how much weightage through those concepts. You can easily expect 2 to 3 marks, 3 questions from this chapter. Numericals as the theoretical part, or the or FIB as the numericals. So without any further delay, let's get started. Let's start with the basic concept, rate of reaction. Here we are talking about how speed the reaction is happening. Okay, so in the equilibrium we talked about this, how spontaneous, whether the reaction will happen or not. Okay, in thermodynamics we talked about what are the conditions to reaction takes place. Equilibrium, how reaction is taking place. In this chapter we are going to talk about how speed, how easily, or what is the speed of the reaction taking place. That's what we are talking as rate of the reaction. So rate of the reaction is a change in concentration of reactants or products per unit time. So for example, A is giving B. So upon varying the concentration of A, will that affect the formation of B or not? So that is what this chapter, kinetics chapter, is all about. So rate equation, how you can write, that is delta A of concentration, or D A of concentration divided by with time dt, which will give you D B concentration divided by time. Okay, so the mole per liter per second, that is the unit for rate of the reaction. So please note that this as a question can be asked. And so ma'am, you are talking about how speed the reaction goes and what are the factors affecting the rate or the speed of the reaction. The first thing first, by seeing physical state. Gaseous state reactions will take place fastest, and then comes liquid state, and then comes solid state, because we know the intermolecular distance between the gaseous particles are less when we are compared to liquid and solid. Okay, and talking about the surface area, the finely divided solids react faster due to increased surface area. We will be using fine powder of nickel, carbon, those as a catalyst, to those as a reaction mixtures in some reactions to enhance the speed of the reactions. Okay, the second thing, that is concentration. The rate is directly proportional to concentration, right? As soon as you are adding more and more of the reactant, you will get more and more of product. If you're practicing more, you will get more marks. That's it, right? So that's what the concentration is about. And then temperature. So here you need to understand one thing, how concentration affects the rate of the reaction is that more the concentration, more will be the molecular collision, right? So how the reaction taking place? So molecules will collide each other in the reaction vessel. So once the collision is successful, then that will cross the barrier to form the product. So that is how the products are formed. So more the concentration means the more will be the collision because more particles are there, and less concentration means less product. That's it. Okay, temperature. Rate increases significantly with temperature. Here you need to understand the rule of thumb, that is rate approximately doubles for every 10 degrees Celsius rise. Okay, this part we'll be using it in another formula. We'll talk about that in a minute. Then catalyst, increasing the catalyst. What is the duty of catalyst? It will alter the rate of the reaction. So if that is we are using the positive catalyst, it will enhance the rate of the reaction, speed of the reaction. Okay, how it is doing that purpose? A graph of energy of the particles, or you can take potential energy, and then reaction coordinate. So with this graph you can understand the entire chapter. So what it says about, let's say the reactant mixture starting from here. Okay, higher the energy means it will easily participate, right? So it is starting from here, let's say. Then collision happens, and when it reaches the barrier, the reaction energy will get decreased and the product will be formed. So product is having lower energy than the reactant. If the product is having higher energy means that won't be stable, right? Okay, so this barrier that needs to be crossed to give the product. Okay, so what is the use of catalyst over here? Let's say I'm starting it from the same point and it goes like this. What is the difference over here is that by the using of catalyst, it need not to jump that much big barrier. For example, if you are having more motivation towards your exam, then you will study more, right, to get more marks, to ace this JEE Main. So, catalyst is the person who motivates you. Similarly, in the reaction, catalyst is the person who motivates the reacting mixture to form the product. So that it need not to climb that much big mountain to reach the product, it just got down. So this is the effect of the catalyst. Okay. This is with catalyst and this is without catalyst. There are many types of catalyst. It can be, catalyst is the one, it's not always speeding up the reaction. There are some catalysts which is called poisonous catalyst. For example, in Rosenman reduction, we use barium sulfate as a poisonous catalyst. That was a question asked in 2014. So the job of poisonous catalyst is that which reduces the speed of the reaction. So through that, it will take more time to form the product. In some cases that is also needed, that's why we are having some poisonous catalyst as well. Okay. So let's move on to the rate law or order of the reaction. So rate law, which is the says about the mathematical expression relating the rate of the rate with the concentration of the reactants. Okay, so let's say A moles of A and B moles of B giving us the product. The rate will be written as, which is proportional to concentration of A and concentration of B. Okay, to remove that proportional symbol, we have to put a constant. That is constant K. So constant K, A moles of A which is having A moles, and then B is having B moles. Here comes the order with respect to each reactant. So what is order is that it is a sum of the powers of the concentration terms. It's just a power. X plus Y will become an order. It is derived from the rate law expression. What we are writing it here, that is a rate law expression, and it may be 0, fractional, or it may be integer. Okay, so it is applicable to only elementary and as well as the complex reactions. It applies both elementary and complex level reactions. What about molecularity then? We'll see that in a while. Let's see what are the types or what are the order of the reactions we have. The first one is zero order reaction. So zero order reaction, which means the sum of those power of the concentration will become 0. The rate, which we are writing it as A to the power 0, that gives K. So rate, which is equal to the rate constant. The rate independent of the concentration, now it becomes half-life is proportional, directly proportional to initial concentration. So how you can write the half-life? That is T half. Half-life, we know that is nothing but to attain the 50% concentration of the reactant, how much of a time that is taking, right? So T half, which is equal to concentration of A for zero order reaction divided by 2K. So if I'm plotting the graph for zero order, rate versus concentration becomes like this, and then the unit of rate constant here, that becomes mole per liter per seconds. Let's move on to first order reaction where n is equal to 1 and the rate equation becomes K, rate is equal to K into A to the power 1. Half-life is T half, which is equal to 0.693 divided by K. This equation is super important. Mostly half-life questions will come from 0 and first order. Half-life is independent of initial concentration. Examples of radioactive decay, decomposition of N2O5. And the unit is second inverse. This is an important question. And if I'm writing a graph for rate versus concentration, then it goes as a linear increase, this straight line. As the concentration increases, rate will also increase. Then talking about the second order, either there are two chances, A and B, which is having the power of 1 and 1, or only one more reactant is there that is having a power 2. Okay, the half-life becomes 1 by K into the initial concentration of A, and the unit of second order reaction, that is liter per mole per second. So if I'm trying a graph between rate and concentration, here the concentration becomes concentration to the power 2, is it? So it is also linear straight line. Then comes third order reaction. Third order reaction, they won't be asking much questions about that, but you can consider the rate under concentration slope will also becomes, I'm taking this easy case, that is concentration to the power 3. Third order, that can be of more types. There can be 3 reaction molecules, 1 to the power each, or 2 reacting molecules, 2 for 1 power and 1 for another power, and only one reactant that is having the power 3. So there can be of many possibilities for third order reaction, and the unit that becomes mole per liter per mole per second. So the simple way to write the unit of any order reaction, that is mole. Third order becomes much more complicated because that is having more than 2 cases, 2 possibilities you can consider, and the questions can be asked from any order reactions. For example, unit, they can ask the 10th order reaction as well. What is the unit for 4th order reaction, 10th order reaction? So that follows a simple formula: mole liter inverse to the power 1 minus n. N belongs to order. Then second inverse. So let's say they are asking for 4th order reaction. Okay, so mole liter inverse 1 minus 4 second inverse. So which will become mole per liter to the power minus 3 second inverse. Okay, so unit can be asked from any order of reactions. Now let's talk about molecularity. So what is the difference between order and molecularity is that I have told you order can be written for elementary reactions as well and complex reactions. In case of molecularity, it is only applicable to elementary reactions. Ma'am, first of all, what is molecularity? It is the total number of species taking part in the reaction, chemical reaction. It's just a theoretical concept. Okay, how many number of species taking part in the reaction? That is what the molecularity talking about. It is derived from the mechanism. It's not from the straight equation. It neither be 0 nor be fractional. It's just a whole number always. But in case of order, that can be 0, fractional and integer as well. Okay, so that is the main difference, and molecularity will mostly that will be less than 3. And reversible reactions, you can write dx by dt for forward, which is equal to dx by dt for backward. What about integrated rate laws? So integrated rate law, which is just a next form of the 0 order, first order, second order equations. The rate law equations are given over here and the plot details. Mostly they will be asking questions in the formula and sometimes in the plot. Okay. 0 order and the first order are very, very important. Now comes the interesting part, that is Arrhenius equation. This formula is super important how many important marks you want to give, you can give it to this formula from this chapter. That is K is equal to AE to the power minus EA by RT. Okay, so K stands for rate constant, A is pre-exponential factor or frequency factor, you can say. EA, that is activation energy. Exponential factor, and this is activation energy. R is gas constant, and T for temperature. Right. So upon taking log for this equation, you will be ended up with this log A minus EA by 2.303 RT. So what if I am having more than one temperature? Let's say two temperature. So this equation, log K1 by K2 by K1, which is equal to EA, that is activation energy, divided by 2.303 R T2 minus T1 divided by T1 T2. Okay, so that is what Arrhenius equation. What is activation energy, ma'am? Then that is a minimum amount of energy required to cross that barrier. Okay, required to cross that threshold to participate in a reaction. That is what the activation energy is. We already talked about that barrier, right? So let's move on to the collision theory. We already talked about how the reaction happens. It undergoes collision, and then once it reaches it gains that energy, it climbs that mountain to participate in the reaction. If there may be two chances, either the collisions can be successful or unsuccessful. The unsuccessful reactions will not lead to the product formation. Only the effective collisions or successful collision will lead to the product formation. Not all the collisions are result in product formation. Okay, not all the students will get clear JEE Main. Only the students who are doing hard work and smart work, they'll clear the examinations, right? So your hard work pays for you. Please do practice more and more questions, gather more and more informations. So what are the factors determining the effective collisions? The first, energy factor. For an effective collision, the colliding molecules must possess certain amount of energy so that it can cross the barrier to create a product. The second factor is orientation factor. So orientation is talking about spatial arrangement. So it should have a proper spatial orientation. So for the simple molecules, P, that's probability of correct orientation, that will be more or less 1, approximately 1. And the complex molecules, that is very less than 1. Then this part, collision frequency. The number of collision happens per second per unit volume, which depends on concentration, we already discussed about it, temperature and size, physical state. Okay. The concentration increases, collision will also get increased, the number of collision frequency will also get increased, temperature increases means collision will also get increased, size of the molecules that also affect physical state, gaseous product will undergo more collisions, right? Then there are some mathematical expressions for finding the rate constant. K is equal to P, that is orientation factor, Z, that is collision frequency, E exponential to the power minus EA, that is activation energy, RT we know, right? So this is a formula for finding out the collision frequency. So let's solve some questions. The first question, which is asking for the high order reactions are rare due to the shifting of equilibrium towards the reactant due to elastic collisions. So what are the reasons? So they are saying that is a high order reaction. High order reaction means it's more than 3, isn't it? So for high order reactions are becoming rare because of these elastic collisions. Why is it so? Because rho probability of simultaneous collisions of all the reacting species. If there is more than 2 or more than 3 products, 3 reactants, so the collision happens between the correct molecules will become less. Okay, so that is the reason this is asked in JEE Main 2014. Then the second question, for the non-stoichiometric reaction, 2A plus B gives C plus D. The following kinetic data were obtained in the 3 separate experiments, all at 298 Kelvin. The rate law for the formation of C is. So that is the question. So initial concentration they have given. They are asking for the rate law for the formation of C. What you can observe here is that from the given data, if I am keeping B as a constant and doubling A, you can see over here, if I am keeping B as a constant and doubling A, it is affecting the rate of formation of C, right? But if I am keeping A as a constant, if I am doubling B, it is not affecting the rate of formation of C. So which clearly says that it is dependent only on A, not B. Right? So what would be the answer to this question? Which option which are not having B? So correct option is A. This kind of simple questions and numericals will be asked in this chapter. So this chapter will give you free marks. Let's consider this question. Ag plus BH gives the product. When concentration of both the reactant G and H is doubled, the rate increases 8 times. However, when concentration of G is doubled, keeping the concentration of X fixed, the rate is doubled. Okay, so the overall order of the reaction is. So how we can find what would be the order? So we know the order is the sum of the power of the concentration of the reactants. Is it? So what it says, doubling G, it's leading to doubles the reaction. Doubles the rate. So the reaction is first order with respect to G. Is it? So that's why it is becoming G square. Okay. So what about other thing? Doubling both G and H. Okay. So doubling G and H. The rate increases by 8. So how it will get 8? Because 2 and 2 to the power 2, that is for G. 2 to the power 2, that is 4, 4 into 2, 8. So that is how this has become 8 times, which means it is a second order with respect to H. So for H, that is second, and for G it is first order. So how we can write the overall order? So first and second total it becomes 3. So answer to this question is option D.